All right. Exponential functions take 5. Exponential functions takes 1 through 4 with trash, and it's only the best for you all. This is going to be a shorter lesson because we've got our assessment for the other portion of class, but it is an important topic, and it's going to help you think about functions more analytically and less procedurally. The objective of today is to find limits of exponential functions at infinity. When I say that term at infinity, I'm talking about the x. I'm talking about, is x going to positive infinity or is x going to negative infinity? That's what I mean by at infinity. And these are a little tricky to evaluate with exponential functions. What do I mean by an exponential function? I mean these ones below where you've got the x variable, the input variable in the exponent portion of your function. So say we had 2/3 to the power of x minus 1 minus 2. First, just like visually, what is this going to look like as a graph? Here it is. If I asked you to find the limit of f of x as x approaches negative infinity, I'd be asking what happens to your outputs as we go further and further to the left. In this case, as we go further and further to the left, those function outputs are heading towards positive infinity. So the limit as x approaches negative infinity of that function is positive infinity, versus as x heads towards positive infinity, our y values, our outputs, are heading towards this horizontal asymptote of -2. We're going to see why that happens in a second. Go ahead and try this next one on your own. Just make sure you're with me here on analyzing these limits graphically. Okay, so what we should have had, again, negative infinity towards the right, or sorry, towards the left. As x approaches negative infinity, our outputs are approaching -2, getting closer and closer and closer to -2, versus our outputs as x approaches positive infinity, our outputs are approaching positive infinity as well. This is going up forever as it's going right forever. So from a graph, not bad, but when we look at these analytically, it's going to be a little tricky, but I'm sure you can get there. Here we go, exponential functions at infinity, analytically. What if we had this function, 2/3 to the negative x minus 1 minus 2? And I asked you to sketch me this graph without the use of a calculator. It's basically 3 things that would be really useful to drawing a nice sketch. One is the y-intercept. What is y when x is 0? That'll be pretty easy. But then finding out what happens as x goes to positive and negative infinity is not particularly easy, and there's no step-by-step process I can tell you. It's just thinking about what would happen as x becomes the largest possible positive number or the largest possible negative number. We'll start out here. We'll start out by just reminding ourselves of how these fractions and exponents work by plugging in 0 to find the x-intercept, meaning we're going to find where this graph crosses the y-axis. I'll do this part up here. If we had f of 0, I'm looking for 2/3 to the negative x minus 1. So we have -0, that's just 0, minus 1, all of that minus 2. We have 2/3 to the -1 minus 2. Remember, negative exponents, this means 1 over 2/3 to the positive first. So 1 divided by 2/3. We've got here 3/2 minus 2. That's 1.5 minus 2. We're going to call that -0.5. So I'm going to go ahead and put a hash mark at 1 and a little y-intercept there at -0.5. So just, yeah, that's how that exponent works. That's how that exponential function works. Now, we have to actually analyze this. We can't just say 2/3 decay. We have to look at this because we're not sure what's going on with the exponent. Notice we have a negative x in the exponent, so it's not quite that straightforward. So let's walk through it. If we wanted to find, I'll try and do red for left, green for right. If we wanted to find the limit as x approaches, let's actually do, let's do the left first. It ends up being easier in this case. The limit as x approaches negative infinity. So we're going to do negative infinity first of f of x. Can't have a naked limit. Now, when doing these limit statements, this is going to be an AP Calc scoring guide tip. You never write equals until the very end because any intermediate step may not actually end up being true, and you want to wait to write that final equal statement until you're done. I'm going to put scratch work below it. My first step here is I'm going to think about what happens if I plug in infinity. And so if we plug in infinity, what we have is 2/3 to the negative infinity, right? Notice there's already a negative in the exponent, so we're going to have negative infinity. That's positive infinity, minus 1, all of that minus 2. Now the key idea here is that if you've got infinity minus 1, or at least you're heading towards that, that minus 1 is going to become irrelevant. You can ignore it. For all intents and purposes, it doesn't exist. As x is approaching negative infinity, it's going to end up not mattering. Once you get to a billion minus 1, is it really that different from a billion? You get the idea. We can just say infinity. Okay, so 2/3 to the infinity. Well, think about what's happening here. 2/3 to the 1, that's 2/3. 2/3 squared, that's 2/3 times 2/3, 4/9. Let's say if we did times another 2/3, we'd have 8/27. If you take a fraction and you keep raising it to larger and larger and larger powers like that, and by fraction I mean less than 1, it's going to head towards 0. So this is actually going to, as we approach infinity, this is going to tend towards 0. It's going to approach 0, but then you've still got this minus 2 hanging out. You've still got this minus 2 hanging out, so the limit as x approaches negative infinity is actually negative 2. And so I'm going to remember that. I'm going to draw this horizontal asymptote. And we'll come back and we'll look at it again at the end. But basically what's going to happen is, and this is tricky because I got to do these backwards, your graph, I did it wrong. Your graph is going to approach negative 2 as x heads towards negative infinity. Let's see what happens towards positive infinity, and we'll be able to finish this off. So now let's see what happens as x heads towards positive infinity. The limit as x heads towards positive infinity of f of x. Same thing, let's plug in our infinity. We'd have 2/3 to the, now we have negative infinity because of that negative sign, minus 1, all of that minus 2. Same idea applies. That minus 1 becomes irrelevant. Now 2/3 to the negative infinity, all right, is a little trickier because we've got, say, 2/3 to the negative 1. That would be 1 over 2/3, 3/2. Then we'd have 2/3 to the negative 2. That's 1 over 2/3 squared. That's 1 over 4/9. That's 9/4. And so it's just creating the reciprocal here. In the infinity case, 2/3 goes to 0. But in the negative infinity case, if you're doing 1 over, one way to think about this is the same thing as saying 1 over a smaller and smaller and smaller number. This is almost like saying 1 divided by 0. You're getting closer and closer and closer to 0. And so if you're getting closer to 0, but you're not getting there, you're actually heading towards infinity. So it's not really that, but that's a way to think about it. You're going 1 divided by a smaller and smaller and smaller fraction. This is positive infinity, minus 2. Who cares about minus 2 from infinity? It's just infinity. So our limit as x approaches infinity is positive infinity. So to the right, we're heading up forever. To the left, we're approaching this asymptote at negative 2. And so combining these two, green and red make purple. Just kidding. We would have a graph that looks something like that. Key ideas here again, you can find the x-intercept by plugging in 0, or sorry, find the y-intercept. And then you just have to logic through what's happening with these numbers. Are they getting larger? Are they heading towards infinity? Are they heading towards 0? Am I dividing by them? There's a lot of things to think about, so you just need to analyze the function all the way through. Let's do one more and then one on your own. Let's say we had g of x is negative, pause, 2 to the negative x minus 1. I'm pausing there because this can be really easy to miss. It's really annoying here. But unless that parenthesis is around the negative 2, you can assume that the negative is the last thing that happens. Only 2 is getting multiplied to that exponent. So that negative is outside the exponent. So let's say first, just like we did before, let's do g of 0. That's negative parenthesis 2 to the, 0 minus 1, this is negative 1 again, plus 2. Negative 2 to the negative 1 is 1/2. plus 2, negative 1/2 plus 2. Okay, we got 1.5. So once again, there's our x-intercept. In this case, it's at 1.5. Let's think about what happens as x heads to negative infinity. Limit as x heads towards negative infinity. Not going to write this yet. I'm going to just do scratch work down here. We'd have negative 2. I got to stop saying that so quickly. Negative, pause, 2 to the negative x minus 1. So negative infinity. This is positive infinity minus 1 plus 2. The minus 1 stops mattering. Okay, so 2 to the infinity, that's infinity. And then that negative sign happens after. It happens last. So we're going to have negative infinity plus 2. We're going to have negative infinity. Okay, so we're getting somewhere. As my graph heads to the left, it's heading towards negative infinity. Let's see what happens to the right, and then we'll be able to draw the full picture. The limit as x heads towards positive infinity. So we'd have, oh, I did it. I did a naked limit. Got to put g of x there. Do that on the AP exam. You're going to lose some really silly points. Got to say what you're taking the limit of, or it doesn't make any sense, of g of x. So we have here negative parenthesis 2 to the, now when I plug in infinity, we have negative infinity minus 1, but that minus 1 isn't going to matter next to infinity, plus 2, negative 2 to the negative infinity plus 2. Now notice I haven't crossed out the 2 yet, right? That's interesting. Why did I cross out the negative 1 but not the 2? Because the negative 1 was with that infinity. And the 2 isn't quite yet. We have to see what happens. And here's a good example. 2 to the negative infinity. That's 1 over 2 to the infinity. This approaches 0. That's why you can't get rid of that 2 yet, because that ends up being your horizontal asymptote at 2. So we have a horizontal asymptote to the right at x equals positive 2. So to the right, we approach that asymptote. To the left, we head down towards infinity. Green and red make purple. There we go. That's what that graph would look like. Go ahead. I'm going to give you pause on this one. Try this one fully on your own. Give you space on Edpuzzle to try this. I'm going to ask you 3 questions. I think do them one in a row to see. 1, I'm going to ask you what is f of 0? Or, yep, what is f of 0? 2, what is the limit as x approaches negative infinity? And 3, what is the limit as x approaches positive infinity? All right, so first one up, what is f of 0? F of 0 is negative 1/4 to the 0 minus 2, that's negative 2 plus 3. Negative, okay, 1/4 to the negative 2, that's going to be 1 over 1/4 squared plus 3. That's going to be negative 1 over 1/16. So that's going to be negative 16 plus 3. That's going to be negative 13. So I'm going to maybe go by like 5s here. 5, 10, 15, and we'll say right there, this is negative 5, negative 10, negative 15. So when we plug in 0, right, we have negative 1/4 to the negative second, ends up being negative 16. Plus 3 is negative 13. Let's see what happens with our limits. The limit as x approaches negative infinity, do our scratch work here, we'd have negative 1/4 to the, okay, negative x minus 2, that becomes positive infinity minus 2. Positive infinity minus 2 is just positive infinity, plus 3. Okay. A fraction to infinity, like less than 1, 1/4 times 1/4 times 1/4 times 1/4. In this case, this is heading towards 0. 0 plus 3. The limit as x heads towards negative infinity is in fact positive 3. So we'll do a line here, the line y equals 3. let's see what happens on the other side. So what is the limit as x approaches positive infinity of g of x? Gotta stop writing these naked limits. It's clearly been a long summer for me. Here we go. Let's plug in negative 1/4 to the, okay, now I'm plugging in positive infinity, so negative x minus 2. This becomes negative infinity plus 3. Now, we just saw that 1/4 to the infinity was 0. So 1/4 to the negative infinity, 1/4 to the negative infinity, that has to be infinity because it's 1 over that thing that is approaching 0. So again, this, right, this is heading towards 1 over, I'm going to do some like made up notation here, a number that's heading towards 0. So we actually have here negative that thing plus 3. This thing is heading towards infinity, so we have negative infinity plus 3. Now who cares about the plus 3? Our limit to the right is negative infinity. Okay, so there's only one way that this is going to happen. I need to cross through that x-intercept. I need to cross through that x-intercept of negative 13, and I also need to have a function where if I approach and if I go towards negative infinity, I'm heading towards that asymptote. But as I head towards positive infinity, I'm heading to negative infinity. This is kind of a tricky one to draw here, but it's going to look something like that. Something like that, so that as x approaches positive infinity, f of x is approaching negative infinity. As x approaches negative infinity, f of x is approaching 3.